Hello everyone. In this video, I will walk you through some basic concepts of C language using simple beginner friendly examples. For many of you, this might be the very first programming language, so I will do my best to explain each concept in a clear and easy to understand way. Before we get started, I just want to mention that this video is a part of my college assignment. So, I would like to thank my college, CMR University, and my professor, Dr. Nagaraj Cholli, for encouraging me to create this educational content. So, without any further delay, let's get started. Let's quickly go through the topics covered in this video. What's a programming language? C basics, variables, data types, constants, keywords, comments, input output in C, and lastly, instructions and operations in C. Let's start with our first topic. What's a programming language? We all know that computer is a powerful yet dumb machine. It lacks the ability to think or to make decisions on its own. It requires specific instructions to perform tasks. This is where programming plays a vital role. Through programming, we can communicate with the computer, guiding it on what to do, when to do, and how to do it in precise steps. Just as we use languages like English to converse with each other, we need a programming language to communicate with computers. These languages allows us to give the machine instructions in a way it understands. Some of the popular languages you must have heard of include C, C++, Python, Java, and Ruby. Now let's discuss the basic syntax of a C program. The basic structure of a C program looks something like what you can see on your screen. Here the first line hash include stdio.h is the preprocessor directive, where stdio.h is a header file and stands for standard input output.h. It is a library which consists of primary C functions. In the next line we see int main. Main is where the program actually starts. When we run a program, then the main function is called and whatever inside it is executed. Here in body we have printf hello world, which will print hello world on our screen. Then we have return 0 and the program ends. We will discuss more about the structure later. Now let's go to variables. Variable is the name of a memory location which stores some data. Here I have listed few examples of variable names like marks, which has stored 15 inside it, and star, which has stored a star symbol inside it. All the variables here are given their memory address inside the memory and are stored in the memory. We can give any name of our choice to variables if it follows certain rules. Now let's talk about those rules. Variables are case sensitive. What this means is if we write a variable with uppercase and then we write the same variable with lowercase, then both of these variables are not the same and are different. So we should always keep in mind to check whether the case of the variable is correct or not. The next rule states that the first character can only be an alphabet or underscore. So we can't use digits like 1, 2, 3 or any other symbol like hash, exclamation sign. Next, no comma or blank space is allowed. So we can't leave spaces in a variable name. Next, no other symbol other than underscore can be used. Next, usage of keywords as variable is not allowed. Our next topic is data types. There are four primary data types in C, which are int, that stands for integer, float, double, and char. You can refer this table to know all the kinds of data type present in C. Here you can see the type and the size of the data type and also the range. Data types helps in defining the nature of the data. It specifies what kind of value a variable can hold, like a number, character, or floating point. This way, it helps us to keep the data in a structured manner. It also allows us to allocate the memory efficiently. Each data type requires a specific amount of memory. Knowing the type of data lets the compiler allocate just the right amount of memory. For example, char usually takes 1 byte, int takes 4 bytes, as you can see on your screen for all the data types. Our next topic is constants. Values that don't change and are fixed are called constants. There are two types of constant, numeric constant and character constant. Under numeric constant, there are two types of constant, which are integer constant and real constant. Integer constant include 1, 2, 3, 10, 0, minus 20, minus 24, etc. Examples of real constants are 1.0, 2.0, 0.0, minus 12.07. Under character constant, we have string character constant and single character constant. Examples of single character constant are a, 2, dollar, which are all included under single quotes. And examples of string character constant are hello, 143, hit @gmail.com, which are all enclosed within double quotes. So when we require multiple characters to be stored, we use string character constant. So we use constants when we don't want the value to be changed, unlike variables. So let's now move on to our next topic. Our next topic is keywords. Keywords are reserved words which have a special meaning in the compiler and we can't use them as our variable name. Just like there are words in a dictionary which have their own meaning and we can't change those words, each keyword has its own meaning and we can't change those. There are 32 keywords in C language. The following table shows you all the 32 keywords that are there in C. If you notice closely, you may see that we have already used a few of them, like int, float, and char. Our next topic is comments. Comments are lines that are not part of our code, meaning when the compiler is executing the program, it will ignore these lines. Comments can be anything and in any language, like English, Hindi, or whatever language we choose. There are two types of comments. First is single line comments, for which we use double slash, and then multiple line comment, for which we use a slash and a star at the start and a star and a slash at the end. Now let's try writing comments in VS Code to get a better understanding of comments. Here I am writing a single line comment. Now let's write a multi-line comment. Now let's try running the code so as we know whether the compiler has ignored the comments or not. So as you can see on your screen, here the compiler has only printed hello world and has ignored all the comments. The next topic that we are going to discuss is input output in C. Whenever we are doing programming in any language, input and output are very essential and important parts of it. Here we will learn how to show output in C language and then we will learn how to take input in C language. For showing output in C, we use the printf function. For printf, the proper syntax is like this. First we use printf, we then use parenthesis, and inside, after using double quotes, we can write whatever we want as our output. Then we give the semicolon to tell the compiler that this line is finished here. For new line in C, we use \n. If we use \n inside printf after hello world, in the output first hello world will be printed and then a new line will be created. Now let's talk about the cases for taking user input, storing it in a variable and then printing it on the screen. For the first case we have integers. For integers we use %d where d stands for double. We will talk about double later in this video. Next we have real numbers. For real number we use %f where F stands for float. At the last, we have characters. For this, we use %C. These %D, %F, %C are called format specifiers. Now let's talk about input in C. For taking input in C, we use scanf function. Inside scanf, we first mention the format specifier of data type, followed by a comma, and then using the address of operator, we write the variable name whose value we want to print. Here, the address of operator, denoted by ampersand, stores the address of the variable. So, through the help of scanf, the input value is stored in the memory address of the variable. Now let's do the practice question 1, which is on basic input-output in C. The question says, write a program to calculate the area of a circle. Let's do it on our VS Code. Now let's start our next topic. Instructions. Instructions in C language are commands that tell the computer to perform specific operations. These instructions form the statements in a C program and are executed sequentially unless control flow changes them. The types of instructions are type declaration instructions, arithmetic instructions, control instructions. Now let's talk about the type of instructions in detail. First, type declaration instructions. Instructions which we have to declare before using it comes under this type. I've given some valid and invalid examples for you to refer. The next type of instructions which exist in C are arithmetic instructions. All kind of mathematical operations performed are under this category. Here, if we look at the example of an addition operation between A and B are the operands and the plus symbol used between them is the operator. So, operator is the symbol which tells what operation we are going to perform. Here are some valid and invalid arithmetic instructions for you to refer. Next, we will talk about the modular operator. Modular operator is used to find the remainder. The point to note here is modular operator doesn't work for float or any other data type. It works only for int data type. Some examples are listed here. 3 modulo 2 gives 1, minus 3 modulo 2 gives minus 1. Our next topic is type conversion. Whenever the data types of the operands are the same, then the data types of the output is also the same. But if the data type of the operands are different, then the output type will also be different. When we perform operation of int with int, then the output is int. When we perform the operation of float with float, then the output is a float. But when we perform the operation of int with float, then the output is a float value. Why? Because int takes 2 byte and float takes 4 byte. So the container of float is bigger than that of int. So it can store more values. Here the compiler uses a little bit of logic that when we are performing operation between float and integer, it will need a bigger container than that of int. So it considers the container of the float and hence the output is a float type. Example, if we multiply 2 with 2.0, then the output is 4.0. Let's look at the types of conversion now. We have two basic types of conversion. First, implicit conversion, and second, explicit conversion. When the compiler itself performs conversion on data types, then it's called an implicit conversion. In this conversion, only small data types like int can be stored in float or double, and not the other way around. So, if we declare an int variable and try to store a float value, the compiler won't do it for us. To do this, we have to take the help of explicit conversion and forcefully tell the compiler to convert float into int data type. Now let's talk about operator precedence. The order in which operations are performed step by step is called operator precedence. Here I have made a flowchart for better understanding of you about precedence order. The flowchart here shows the precedence of operators in decreasing order. We give the highest priority to brackets while performing an operation, then to multiplication operator, division operator, module operator, then to plus and minus operator, and at the last assignment operator, that is equals to. Now let's discuss few practice problems on operator precedence. In the first question we see 4 plus 9 asterisk 10. So in this we have to use the operator precedence. According to that, we first multiply 9 with 10, which comes out to be 90, and then add 4, and the final answer we get is 94. In the next question, we see 4 asterisk 3 slash 6 asterisk 2. For this, we use associativity rule, which says when we encounter operators of same precedence, then we do the operations from left to right. So we first multiply 4 with 3, which comes out to be 12, and then divide it by 6, which comes out to be 2, and then multiply it with 2. Then the final answer is 4. In the next question, we encounter the brackets, which are of the highest precedence. So first we divide 2 with 2 and get the answer 1, and then we multiply 5 with 1 and with 3 and get the answer 15, which is our final answer. In the last question, we follow the same rule for the same precedence, and we first divide 2 with 2 and get 1, and then multiply 1 with 3, and at the end add 3 with 5 and get the answer 8 as our final answer. The next topic we are discussing is control instructions. These are the instructions that decide the flow of the program, that is, the order in which program will get executed. There are three types of control instructions, which are sequence control instructions, decision control instructions, loop control instructions. The default mode of execution, where statements are executed line by line in the order they appear, is sequence control instructions. If we look at the example here, first int a is getting declared and initialized with the value 5, and then int b is getting declared and initialized with the value 10. Then int sum is getting declared and getting the value a plus b. So this program follows the basic flow of code line by line and hence is under the sequence control. Next, decision control, used to make decisions and execute certain parts of the code based on conditions. The types of decision control instructions in C program are if, if else, if, else if else, and switch case. Loop control instructions repeats a block of code multiple times. The types of loop control instructions in C are for, while, do while. The next topic we are going to discuss is operators. The following are the operators in C. First, arithmetic operators. This include the basic math operators plus, minus, division, multiplication, and modulo operator. Next, relational operators. This tells the relationship between operands. Example, double equal to, greater than, smaller than, greater than equal to, smaller than equal to, not equal to. Next, logical operators. This perform logical operation between the operands. Example, and, or, not operators. Bitwise operators. This performs operation between zeros and ones. Next is assignment operators. This is used to assign values. Example, equal to, plus equal to, minus equal to, multiplication equal to, division equal to, modulo equal to. Next, ternary operators. This is a conditional operator which makes if-else statement smaller by adjusting it in only one line. That's it for today's video. This was part 1 of our Basic to Advanced C language series. I hope you enjoyed it. Thanks for watching.